Could people turn Mars into another Earth? Here's what it would take to transform its barren landscape into a life-friendly world, by Sven Bilén explores the feasibility and challenges of terraforming Mars to support human life. Terraforming Mars. Author background: Sven Bilén, an engineer and professor at Penn State, specializes in technologies for human space exploration, such as advanced propulsion systems and 3D printed habitats on Mars. Challenges of living on Mars. Essential needs: to live on Mars, humans require liquid water, food, shelter, and a breathable atmosphere. Martian atmosphere. Mars' atmosphere is thin and mostly carbon dioxide, lacking sufficient oxygen and unable to retain heat effectively, leading to extreme cold. Temperature. Nighttime temperatures on Mars can drop to 150 degrees Fahrenheit, 101 degrees Celsius. Possible solutions for terraforming Mars. Creating an atmosphere. Volcanic eruptions. Using nuclear explosions to trigger volcanic activity and release gases is one idea, though it risks introducing radioactive material. Asteroid redirection. Redirecting water-rich comets and asteroids to crash into Mars could release gases and water, aiding atmospheric development. Heating Mars. Space mirrors. Gigantic mirrors in orbit could reflect sunlight to warm the planet. Aerogel. Spreading aerogel on the ground could insulate and trap heat, potentially melting polar ice to create liquid water. Growing food and sustaining life. Soil composition. Martian soil, or regolith, lacks nutrients and contains harmful perchlorates, making it unsuitable for plant growth. Biological solutions. Introducing extremophiles, hardy microbes from Earth, or genetically engineered organisms to convert carbon dioxide into oxygen through photosynthesis. Simulating ecosystems. Experiments like Biosphere 2 on Earth show the complexity of creating balanced ecosystems, highlighting the challenges of doing so on Mars. Building habitats. 3D printing. NASA's program is researching 3D printed buildings that could be pressurized and protected until Mars is terraformed. Radiation protection. Mars lacks a magnetosphere to shield against solar and cosmic radiation. Creating a magnetic field is still speculative and requires further research. Feasibility and ethical considerations. Technological limitations. Current technologies are far from capable of terraforming Mars on the required scale. Achieving this would take centuries or millennia and substantial investment. Ethical questions. The ethics of altering another planet so drastically must be considered. Practical applications on Earth. Innovations for Earth. Technologies developed for Mars, such as 3D printed habitats, are being used to address issues like the housing shortage on Earth. Conclusion. The article emphasizes that while terraforming Mars presents immense challenges, the innovations developed in the process will benefit life on Earth. The conversation around these possibilities continues to inspire scientific inquiry and technological advancement. Source: this article is republished from The Conversation, a nonprofit, independent news organization. Sven Bilén is associated with XHAB 3D, Inc., receiving funding from NASA, DARPA, and the U.S. Air Force.